Today we're going to be going over the basics of differentiation. But before we do that, I'm going to tell you guys about a notation change. So far we've been writing the derivative as this long limit. Writing all this out is really annoying. So the most common way the derivative is expressed is this. And if you want to simplify it even further, it's sometimes written as this. So an important distinction between d dx and df dx is that d dx represents a command. This reads, take the derivative of f of x with respect to x. But df dx just represents the derivative of f with respect to x, like so. Another thing you can do with derivatives is you can take it multiple times of the same function, and its notation is different every time you do it. The first derivative is just represented as df dx. The second derivative is specified with this 2 on the x and the 2 up here. The third is written like this. The general derivative is just written like this. Derivatives can also be written with primes like this. So this reads f prime of x, f double prime of x, and f triple prime of x. But as we take more and more derivatives, the notation changes. So we have the number at the top here, and we'd read this as the nth derivative of f of x. And the parentheses here is super important because you don't want people to confuse this as the nth power of f of x. Now we're going to look at the general differentiation rules, and these can be applied to any function. Later, we'll take a look at specific derivative rules that only apply to certain kinds of functions. Firstly, if I have the derivative of a constant, then this is equal to 0. And the reason this is because if you have the graph of a constant value like this, it'll just be a flat line, and the slope of this is always 0. Secondly, if I have the derivative of a constant times another function, we can just pull the constant out of the derivative, like this. The reason why this works is that the derivative is just a limit, and we already know that we can pull constants out of limits. So if the derivative is a limit, then we can also pull constants out of derivatives. Next, if I have the derivative of a sum or a difference, this is the same thing as the sum or the difference of the derivatives, like so. And again, just like the last one, this works because we can do the same with limits. But this is where it changes a little bit. If we have the derivative of a product, then it's not the same as the product of the derivatives. This is equal to the first function times the derivative of the second function plus the second function times the derivative of the first function, or first d second plus second d first. Like this is not the same as a limit property. So if we have the derivative of a quotient, then this is equal to the bottom function times the derivative of the top minus the top times the derivative of the bottom over the bottom function squared, or bottom d top minus top d bottom all over bottom squared. These derivative rules apply to any and all derivatives, and there are some mnemonics for memorizing them. These are all of the basic differentiation rules. The most important ones you should know are the power rule, the sine rule, the cosine rule, the e to the x rule, and the ln rule. So if I had to categorize these rules in terms of which are most important to memorize, the starred ones you should 100% memorize. These 4 are really good to memorize, and then the last 2 are not really that important or common. By the way, notice that the derivatives of sine and cosine are each other with or without a negative. That means, let's say if you just take sine, you keep taking derivatives, you'll eventually get back to sine. And this cycle becomes pretty important when we look at Taylor series at the end of the course. Also important to know, the derivative of e to the x is itself. I'm going to end the video by doing 2 examples, and the first one we're going to do is we're going to find the derivative of sine x over x cubed. So remember the rule when we have a quotient of functions here. It's bottom d top minus top d bottom all over bottom squared. So I have bottom, so we need to find the derivative of the top, and we know that from the sine rule, the derivative of sine is cosine of x, minus top. Now we have to find the derivative of the bottom. Since this is a polynomial, we can use the power rule. So the power rule is we multiply by the exponent and we drop the exponent by 1. So this turns into 3 times x squared. We multiplied by 3 and dropped it to 2. And of course, this is all over the bottom squared. So altogether, this simplifies to this. And it can be further reduced to this, which is our final answer. And for our last example, we're going to find the derivative of e to the x tangent x. So we have a product of functions here, and we know that when we're taking a derivative of a product, the result is first d second plus second d first. All we have to do is just fill that out. So I have first times, so we need to find the derivative of the second or the derivative of tangent x. So we know the derivative of tangent x from the tangent rule is secant squared, plus second. Now we need to find the derivative of e to the x. And remember, the derivative of e to the x is itself. And this is our answer. It can be further reduced to this. That's an overview of basic differentiation.